This is the practice test for algebra. Here we're working on problem number 15, and the problem states, to a police investigator, skid marks evidence is extremely important in determining how vehicles moved in a collision. Skid marks are the equivalent of a fingerprint in a criminal investigation and just as important. The speed a car is traveling can be calculated using the skid marks made as the car came to a stop. The formula for finding the speed of the vehicle is, and we're giving the speed, the S is the speed in miles per hour, and then we have the square root, and we have these quantities that we need to multiply together under the square root. We have a constant of 30. We have D, which is the length of the skid marks. We have F, which is called the drag factor. And we have N, which is the braking efficiency. And on letter A, we're told a car skids to a stop, leaving 4 skid marks with an average length D of 60. So D is 60. The road is asphalt. Skid tests reveal a drag factor of 0.75, so the F is 0.75. Since all four wheels were braking, the braking efficiency N is 100%, or 1. To the nearest mile per hour, what was the car's speed at the time of the accident? So I put down here the different quantities we need to put into this equation. D is 60, F is 0.75, and N is 1. So the speed of the car is the square root, and we need to, you're going to need to get into the square root function on your calculator and then put in 30 as the constant times 60, which is D, times 0.75 times 1, which won't change the value at all. But when you get these in, then you want to hit the equal sign. You should get this on your calculator. And we need to round this to the nearest mile per hour. To the nearest mile per hour, which is the ones place at the 6. And we look over to the right, we have 7, which is 5 or greater. So the 6 goes up to a 7. And the speed of this car was 37 miles per hour. And then on letter B, we are told, does doubling the length of the skid mark double the speed the car was going? If the car leaves 4 skid marks with an average length of 120, so now we've doubled the length of the skid marks, does the car's speed at the time of the accident double? Use the same drag factor and braking efficiency from part A. Use the car's speed that you calculated in part A to justify your answer. So in this case, D is 120, and F is still 0.75, and N is 1. And we're going to substitute these values into the equation. Remember to use your square root, and you should get 51.96. And we're going to round this off at the nearest mile per hour, the ones place. We have a 9 next to it, which is 5 or greater, so the 1 goes up to a 2. So with skid marks doubled 120 feet, the speed of the car was 52. And is this double the answer from the letter A? And the answer is no. 52 miles per hour is not double 37, so our answer here is no.